Hey, how's it going? Today I'm going to be talking about some of the energy producing solutions or some of the new technologies to some extent. It's been there for some time. It might be very expensive to develop this technology, but I see a lot of benefits of perhaps working on those. For some reason, a lot of people decided in the world to go with nuclear reactors, but perhaps instead of going with those, we should reconsider going with thorium-based molten salt solutions or reactors, and what kind of benefits that can have instead of current way of producing energy. Thorium-based molten salt solutions, often referred to as the thorium molten salt reactors, TMSRs, or thorium fuel cells, are the type of advanced nuclear technology that use thorium as a fertile material in combination with other fissile materials like uranium 233, U233, uranium 233. So that will be a main difference. And from what I understand, one, I don't know if this information is accurate again. So it would require 200 times less in the 1 ton of thorium compared to current way of producing nuclear power, right? So thorium, it would require 200 tons less compared to 1 ton of how we produce them. So output overall, so percentage, right? I have done so many research. I have been looking at so many different informational materials up there to understand this one. The subject is very complicated, but it's more cost effective when it comes to how much material could be potentially used. Where are mineral deposits? One of the largest would be perhaps India. Next one would be U.S. And some of the different companies who are actually working on this technology, they're looking to work on fourth generation of. Ideally, that's the target. They could potentially produce those, but they're very costly, right? So governments will need to, not necessarily businesses. It's not necessarily valuable technology because how much it upfront costs, how much it can potentially cost. So governments might be interested in doing those, and some of the governments that would be India or perhaps China. They're looking for producing those, but they're currently perhaps on first generation, so we need to improve all the way to perhaps fourth generation, where nuclear power is so one that we were understand right now, right? So that potentially worth noting is some of the organizations or countries within Europe perhaps taking notice of those. If we do not really need nuclear bombs, I guess perhaps we can switch to thorium instead. If we need nuclear power bombs, perhaps we need to keep doing what we are doing now. So perhaps that would be, if anything, that would perhaps dual use, right? So where thorium could be only produced perhaps for, perhaps down the line might be improved, and we might be able to find different ways of using it. Other than that, thorium might be an alternative. This technology is distinct from traditional uranium-based nuclear reactors. So it's distinct, is a little bit different. I don't know which one is better, how much study is being done. I know what kind of information is available right now for public. I don't know what that information, if that information is correct. I don't know all the pros and cons. I'm not the. Perhaps I might look like a scientist. I'm a business person. What is cost-effective way, right? So that's what I'm interested in. I don't know. Or from a perhaps science background, it might look a little bit different, especially with some of those people up there who have studied some of the subjects for 20 years or so to understand how to build those reactors, right? Well, myself, I'm interested in business and perhaps running a business. So that's what I'm interested in. So if it's valuable, or perhaps if it's doable, if it's impossible to do, and what would be some of the reasons why not to do it? Thorium is a fertile material. Thorium, usually in the form of thorium 233, TH232 is not directly fissile, meaning it cannot sustain a nuclear chain reaction on its own. So either way, there's a lot of numbers, a lot of formulas. I'm not entirely sure if anyone's interested in those. So E equals mc square, right? So it's very dense. It's very dense material. Let's summarize everything. It's very dense, right? So molten salt, TMSR, use liquid mixture of salt, usually lithium and beryllium fluorides as both a fuel and coolant. This is contrast of traditional solid fuel reactors. The liquid fuel has several advantages, including better heat transfer properties, the ability to operate in high temperatures, and built-in passive safety mechanism. It's always good when we're discussing some of those high temperatures. In the reactor overheats, the salt can expand and move away from the core, which can naturally dampen the nuclear reaction. So overall, it works very similar from my understanding or information I was able to find with regards to safety. I don't know which one is safe. So usually this is what would prevent me from doing it. Everything is very safe. Everything is safe for some reason. Accidents happen. Accidents happen for some reason. How safe they are, and it's very, very, very expensive to do. Why it's so expensive? I can't even imagine why it's so expensive and so safe. I don't know. Safety. One of the significant advantages of TMSRs is the inherent safety features. The liquid fuel and expanded flow out of the core in case of overheat, which prevents catastrophic meltdown. These passive safety features in contrast to traditional reactors which require active cooling systems to prevent overheating. This is what they're saying. There's potentially another layer of safety. So there's a lot of layers, right? If anything, that's the way how I look at it. It's not necessary proof to actually be safe to some extent. Perhaps it has just another layer of safety, but nothing more, nothing less. Reduce nuclear waste. TMSR have a potential to produce less long-living nuclear waste compared to traditional reactors because they have effectively burned through thorium and other fossil materials. This can help mitigate some of the concerns associated with nuclear waste storage. So I have done research to understand that they are taking perhaps only 3% when it comes to nuclear and the way how we're producing right now. We're perhaps taking just 3% and all the rest is waste compared to perhaps thorium where they could almost use everything. So take from 100% they would take just 3% or so, and with thorium that's where that formula of perhaps compared to 200 times better use might come from, right? So how many times they might be able to reuse the same material as well as use entire thing. So perhaps that's difference. But again, I'm not a scientist. There's some research that I was trying to do, as well as those people who are sharing some of those articles. I don't know if that information is correct. Again, I don't know if it's correct. It's a lot of articles out there myself. I'm interested in the subject. Perhaps if we were to roll out some prototypes, small scale, if they were to prove to be valuable, perhaps from those we can progress into larger ones. But again, how much a lot of people have been discussing political support, so I don't know how feasible some of those projects might be. Proliferation resistance. TMSRs are considered to be more proliferation resistant than traditional reactors because they produce fewer weapon-grade materials as byproducts. The thorium fuel cells is less conductive to a production of materials that can be used as nuclear weapons. So what we're comparing against, as well as there are some byproducts as well. There are some inconsistencies. If we're talking about 100%, there might be 2 or 3% of a byproduct that would be able to harm people. So, so this is why they're saying there's no nuclear weapons, but they are, potentially can produce some byproduct that could be harmful to people. challenges despite their potential benefits. TMSRs face challenges or technical challenges, including material compatibility issues with the corrosive molten salt. So, perhaps, from my understanding, because of this reason, some of the testing needed to be done at the time. This is what was one of the reasons why they stopped using it, right, at one time, because of the corrosive molten salt. So that was the biggest obstacle at the time. Some people are saying that they have solved this problem, but again, who can confirm or deny what these people are saying? So if we can solve if we can solve this problem, great. Let's do it, right? But I don't know. I don't know. Fuel processing challenges and the need for advanced materials for the reactor components that can withstand the harsh conditions. Perhaps at the time with some of the technology, they just need to improve some bits and pieces so all the system can function a lot better. Other than that, they have a lot of corrosive properties that can affect what they are saying is corrosive molten salt that can affect all the ends of the metal pipes, from what I understand, right? So all the metal pipes, all those pipes can be affected. Not only perhaps the rods that would need to go down, but perhaps all the pipes. So perhaps they can replace that or cover with particular, I don't know, paint or something. This all is problem. Or perhaps change with more durable metals. Perhaps that would be some of the ways of how they can improve that. But a lot of smart people perhaps are already working on that just based on how much this problem can be worth. Disclaimer: who don't like fireworks, right? I don't know. I don't know. I'm just trying to understand the subject. I'm trying to. This subject might be very boring, right? If anything, any takeaway, some of the subject might be very boring for a lot of people. I'm trying to put my work in and trying to understand the subject as well as trying to make it perhaps easier to understand for others and make, make some fun out of it. But either way, let's if we can, let's prevent all the fireworks if we can. Research and development. Several countries and research institutions are conducting research and development on thorium-based molten salt reactors. China, in particular, has made significant progress in developing and testing TMSRs, as well as I find some articles saying that US have started. Uh, India has a lot of access to a lot of thorium, as well as China is doing a lot of research in this space and looking for alternatives, as well as they are looking to improve a lot of areas and perhaps they have necessary funds available. People out there who are interested in learning more, I have published a course, Rise Impact. There's going to be a number of series of books that I'm looking to release. In this book, I'm sharing a lot of information with the people out there who are interested in finding out more about where to begin when starting their own livestock enterprise. In this book, I'm focusing on how to achieve your first milestones. That would be from zero to a first 10,000 euros dollars pounds and how to achieve this first milestone. In the book, I'm sharing a lot of examples with the people who would like to learn more and understand principles, what would be required, what they would need to know. And some of those principles potentially can save you a lot of money, right? If anything, people are sharing in this book a lot of information. I'm taking a lot of knowledge, a wealth of knowledge from others who have been there, done it, and they're sharing a real life examples of where you can improve and learn more. You can find it in the description below as well as Top Retailers has it. While thorium-based molten salt reactors hold prominence for the future of nuclear energy due to their safety features and potential to reduce nuclear waste. So they looking to solve some of those problems compared against current ways of doing it, but that's not to say that's perfect, right? Let's acknowledge that it's not the perfect way of doing it. Perhaps it's better compared to what we're currently doing, but there's a reason why we're currently doing this particular way. So we as a society would have nuclear power weapons. So that's the reason why we're doing currently in this particular way. And thorium can potentially reduce need of nuclear weapons, but is it? Or we as a world need to have those again? So as well as investing a lot of research and energy in working on thorium, perhaps, which can offer some alternatives, right? They are still in the experimental and development stages. Widespread adoption will require addressing technical, regulatory, and economic challenges, since it can be very costly, and access to talent who might be interested in doing a lot of research within this area might not be that easy. So if any takeaways, right? If you are a business person right now who is interested in this technology, you might have abundance resources sitting in a back garden. You might be interested in taking that resource and powering up to produce electricity or energy, right? If you were interested in doing that, you need to find professionals who can do it. How you can find those? And if you were to find those, how would you be able to bring them on board to work with you, right? What you need to offer those people, right? If it's handful of those available of that. So again, if anything, I would like to bring more attention to a lot of people out there. This is how you can potentially solve any problem, right? You need to find the right people, have access to finance, and find all those opportunities up there, as well as mitigate your risk, all the good stuff, and you can potentially offer a lot of value to large groups of individuals, hopefully, with, if anything, addressing all the safety features and no fireworks. Thanks for watching. I'll see you in the next one.